Hello and welcome, my dear students and my viewers, to my channel Mathematics Made Easy. Today's video is again a grade 10 elite special video for all the students who are giving their exams shortly. This is from calculus. Today we are covering the topic of integration, and I've selected some questions as per your scheme of work and as per your exam coverage from the following lessons. You have the page number and the question numbers mentioned here. So let's dive into the video, and before we do that, a humble reminder to all the students which are watching my video and I've been benefiting and liking them for preparing for the exam. Please request to you, please subscribe to the channel and press the bell icon. It serves as a good motivation for me to make more and more videos for you. So let's dive into the video now and see what questions we are covering today. So just to before solving some integration questions, I have put here on the screen a brief summary of the integration techniques. In today's session, we are going to be solving questions on integration by substitution and integration by parts. So just a slide of formulas and integration techniques for a good, reference point for solving questions. So this is in front of you. Let's use it for solving questions sheet before we move to some questions. So here we are going to look at indefinite integral. Indefinite integral is the integral which does not have lower and upper limits. So you denote your integral like this, where c is the constant of integration, this c, and f of x is the antiderivative of fx. So we have to find the antiderivative here, which is the integration or the integral. This is called indefinite integral, and this one which has limits a and b is called definite integral. Both are opposites. Then is fundamental theorem of calculus. So this theorem is very important. We use this theorem for solving a lot of questions. So condition is if f is continuous function on closed interval ab and f of x, the capital one, is antiderivative, then the definite integral a to b fx dx is found by substituting the limits, that is upper limit f of b minus lower limit f of a. It is also denoted the difference by writing f of x such that it rises from a to b. Here a is usually lesser than b. So this is the first technique of integration that we will use today is integration by substitution. I will shortly show you a question how to solve this from the end of term coverage. So first step is to choose a new variable. Generally you take any other variable like u and then you compute du over dx. So you are differentiating with respect to u, with respect to x, the new variable u, and you are using this conversion factor. Generally the expression which is connected and which is selected as u is the innermost expression or the inside term of a composite function. Then you replace all the terms in the original integrand which is given in terms of dx to u and du. You change it, and then the resulting integral which is in u that you've got, you'll try to solve it, and you'll try to in the end replace wherever there is u with the expression in x, the one that you had selected in the first step. So let's see how we use this for solving questions. Okay, so in today's class, we will be solving all of these questions. The important ones we'll be picking up, where we are going to do integration by different methods, like integration by substitution, integration by using power rule, using integration by parts, and also by using the integration when the numerator is the derivative of the denominator. So let's solve some questions from this list, and all of these questions are taken from your end of term coverage. So make sure you follow my channel. Make sure you watch the video till the end. Let's do integration by substitution. We'll be solving these two questions out of the one that you see on the screen. So let's do first answer 7. So here integral is given x cube, and inside the square root you have x to the power 4 plus 3 dx. Now first you have to identify that the inside term is usually taken as the new variable. So we'll take u as this one and then differentiate du over dx. What do you get? Difference power rule for derivatives gives you this. So du is equal to 4x cube over dx. Now you see x cube, you see dx. So x cube dx you will isolate, so it will be du by 4. So now in the original integrand you will replace x cube dx with du over 4. Already the inside term is square root of u, so this reduces to 1 by 4 square root of u du in the integrand. So this square root is same as u to the power 1 by 2. So now we can go for power rule. Power rule gives you u to the power 1 by 2 plus 1, 1 by 2 plus 1, and you add c to it. Last step, you replace back the value of u. So 1 by 4 u to the power 3 by 2. Now this becomes 2 by 3 plus c. So let's put the value. This is 1 over 6 u to the power 3 by 2 plus c. Now u we had taken as this value, so 1 by 6 x to the power 4 plus 3 to the power 3 by 2 plus c, where what is c? C is the constant of integration. Okay, so this is going to be the final answer for 7. Let's do question 14 in the next slide. Okay, so let's solve question 14. This will again be done by integration by substitution method. So we are going to choose another variable u from here. So we usually choose the inside function. So let u be e to the power x plus 4. Then you differentiate both sides with respect to x. It is e to the power x only. So we can replace du with e to the power x dx. So the two things e to the power x dx in this would be replaced by square root inside is u times du, as you see. So this is same as u to the power 1 by 2 du. So now we can go for power rule. 1 by 2 plus 1, 1 by 2 plus 1 plus c, the constant of integration. So this is u 3 by 2 over 2 by 3 plus c. Now we'll put back the value of u. So u was taken as e to the power x plus this. So 2 by 3 times e to the power x plus 4 plus c is your final answer. I hope now you've understood integration by substitution. The remaining problems you try yourself. Some students were asking me for the answer key for all the question. So if I make the video for all the question, it will become very long. Already the videos are 20 to 30 minutes. So what I'll do is next week, just wait till Monday or Tuesday. I will prepare the answer key as a PDF or as a presentation and put it on a shared folder. I will share the link of my Google Drive with you, and you can download the formula sheet, the revision handout, the end of term, and the answer key from there. So just wait for the next week and you will get all the answers to the question. Let's now understand the power rule. So the power rule for integration is opposite to the power rule that you've done for differentiation. So here when you are integrating x to the power n with respect to x dx, it will be equal to x to the power will increase by 1. Okay, and then gets divided by n plus 1 plus c, where c is the constant of integration. Okay, it will remain like c for a indefinite integral. Let's take an example. So if you have x to the power 5 dx, then your power is 5. So its value will be x to the power 5 plus 1 over 5 plus 1 plus c, which is equal to x to the power 6 divided by 6 plus c. So here you just see you increase the power by 1 and divide by the same. That's your power rule. Let's solve some ministry questions from end of term coverage based on power rule. So as per the end of term coverage document, question 12 to 21 are important. In today's session, we are going to be solving question 13, question 17 and question 21. These are important one by one. So let's start with question 13 followed by 17 followed by 20. Okay, so I'm solving question 13 first. We are going to use power rule for this. So I'm going to break, there are 1, 2, 3, 4 terms. So I'm going to write this 4 terms in terms of 4 integrals. So the variable of integration, as you see, is n. So dn and n variable inside. Okay, minus 9n square dn, that's the second integral, minus 18n dn, third integral, and last one is 4dn. Now, when we integrate n cube, 20 is a number, it comes outside the integration as a constant. So when I integrate n to the power 3, n is, the power is 3, so it will become 3 plus 1 over 3 plus 1. That's for the first part. Minus 9 comes out, n to the power 2 plus 1 over 2 plus 1 for the second. Minus 18, here power is 1, so n to the power 1 plus 1 over 1 plus 1, minus 4 times n plus c, constant of integration. So final answer is this one. So just simplify, use your calculator and give the simplified expression. We can simplify this little bit more. So 5n to the power 4 minus 3n cube minus n squared minus C. So this is your answer, where C is constant of integration. Now let's also do question 17. So here if you see, there is a difference. It has definite integral. So it is going to be a little long question. Let's do it in the next slide. And this definite integral, if you see, the lower limit is 2, the upper limit is 10. So it will go from 2 to 10. We are going to do substitution for this definite integral. Okay, so let's solve this question now on definite integral. I'm going to use fundamental theorem of calculus for this. So the derivative, the integral of a to b fx dx would be f of b minus f of a. So if you see, a here is 2, the lower limit, b here is 10. So we are going to substitute a and b in the formula and use the fundamental theorem of calculus to solve this. So first let's do power rule. So 1, 2, 3, 3 terms are there. I'm going to divide the integral into these 3 parts. P to the power 1 by this, and the variable here is p with respect to which we are integrating. So these are the 3 integrals: 1 by 4 dp integral 2 to 10. Now the numbers, the fractions will come outside, and inside power will increase by 1 and divided by the same quantity. Now here the limit is from 2 to 10, so we are going to substitute from 2 to 10. I'm writing in this format, this one. So I'll just change the brackets here and we'll write in this way. This vertical line with 2 to 10 means we are going to do substitution in the next step. Similarly, power 2 by 7 plus 1 increase by 1 divided by the same thing, 2 to 10. Last, 1 by 4. Here you don't have any variable, so it will be p and substitution 2 to 10. Let's simplify this further. So this will be 2 by 5 p to the power 1 plus 8. So LCM I'm taking, it will be 9 over 10 over 9 over 8. Then 2 to 10 plus 5 by 4 p to the power 9 by 7 over 9 by 7. Again, the limits are 2 to 10 that we are substituting, plus 1 by 4 times. Now this is simple, 10 minus 2, so 8. In the next step, it will reduce to 2. Now we'll do some calculation. 2 by 5 times 8 by 9, p to the power 9 over 8, and now limit is 2 to 10 plus 5 by 4 multiplied with 7 over 9, p to the power 9 over 7, limit 2 to 10. And here see, 10 minus 2 is 8 divided by 4, so plus 2. Now let's simplify a little bit. Let's see if some cancellation is happening. So here nothing is going to cancel, so it is just 16 over 36. 16 over 5 times 9, which is 45. And now we are going to substitute the value of 2 and 10. So it is 10 to the power 9 by 8 minus 2 to the power 9 by 8. Plus, again here there is no cancellation. So 7 5s are 35 over 9 6 36. And again substitution of the limits. And left with 2. So this is your final answer. There is no other cancellation which is happening. So if you want, you can just reduce the power to decimal and reach to some number in the end. So that's your answer for definite integral question 17. Let's now do one more last question on power rule. So here now directly the three numbers I'm going to take outside. 1, 2, 3, 4. There are going to be 4 integrals. So 14.2 outside, integral w to the power 6.1. So the power is a decimal as you can see. Then 20.1 power is a decimal again. Second integral, then 13.2, third integral. Let's just correct this little bit here. So this is 13.2 w to the power 2 by 3 dw plus 3 times dw. Now this is indefinite integral because you don't have any limits on the integral. So power rule, the power increases by 1 and you divide by the same quantity. Same thing you do here, 5.7 increase by 1, 5.7 plus 1. So I hope by now you are getting more comfortable with power rule of integration, which is very different, in fact opposite to the power rule of differentiation. So don't get confused. Now we have done so many problems, so you will be more comfortable. Let's simplify this a little bit. So we are going to add the power. So 6.1 plus 1 would give you 7.1. So 14.2 over 7.1 w times 7.1 here. Then minus 20.1 over, this is 6.7 w to the power 6.7 plus 13.2 over 3.3 w to the power 3.3 plus 3w. Let's do some cancellations and do the simplest fraction that can be possible. So here it will be 2 times w times 7.1. In the next part you divide 20.1 with 6.7, so that gives you 3 w times 6.7. In the next part you do the fraction division of 13.2 with 3.3, that gives you 4 w. This is your final answer. Okay, so let's solve question number 9 now out of this list. This question can be solved using this key concept that when the numerator is the derivative of the denominator, then the integral f prime of x over fx dx is equal to log of fx. So this is the natural log plus c. So here what we are going to do, we are going to substitute u as cos x. So when you do that, du by dx is going to be minus sine x, or du will be minus sine x dx. So let's do that, and the integral becomes negative du over square root of u. That means it is same as minus u to the power minus 1 by 2 du. So now we apply power rule. So minus of u to the power minus 2 plus 1 minus 2 plus 1, and there's a constant of integration. So this reduces to minus minus becomes positive, u to the power 1 by 2 times 2 plus c. So now put the value of u. So we had taken u as cos x to the power 1 by 2 plus c. So final answer is square root cos x plus c. So this is where we have used the concept of integration by substitution. That's one way of doing it. Second way of doing it is you can just write this integral using the formula this one as integral of sin x dx over integral of cos x. So you see here in this integral, the numerator is derivative of denominator. So that is a trick to understand, because sin x is the derivative of cos x. In fact, it's negative sin x. So that's the trick how you understand. You have to go for this substitution. Solve question 16 now. In question 16, again we will use substitution. So as you know, the inside function is taken as the um, new variable. So let's choose u as 1 over x. Then its derivative du over dx, because this is same as minus 1, would be minus 1 x to the power minus 2. So you can write this as 1 over x square with dx is d. So the substitution you are going to use for this would be minus du is 1 over x squared dx. Now this substitution you can do here. So the integral which you need to find reduces to cos u du with a negative sign. Now, what is the integral of cos? It is negative sign. So there's already a negative outside. So this becomes sine of u, which is 1 by x plus c. So that's your answer for question 16. For this video of integration covering the exam of coverage. Next coming up on my channel is exam of term coverage part 4. So make sure you subscribe to the channel, give the video a thumbs up if you liked it and found it useful, and don't forget to share it with your friends and students which are giving exam on 13th of June. See you in my next video. Bye students.